parameters, but I don't have that on the slides.
Good.
Ready to go?
Yes, I am. Oh, it's freezing.
It is cold.
Those doors make it worse.
I can go.
Oh. Better. Let's stay that way for a minute until someone else comes in.
Ready?
Should I start?
Start.
Welcome to Six Man. Yeah, and as we said before, given the shape of the room, you're much better off to sit in closer to the front. Or you may need binoculars to see the slides otherwise. So welcome to London. Okay. This is the note well. I'm sure you all have memorized it by now. So, and we have Jordy and Eric are minute takers, and Mikkel is the Jabber scribe. Thank you very much. Very appreciated. And so this is the agenda, which I can't quite read either. So we have the introduction we're doing now. The two working group documents are being discussed, node requirements update, and the segment routing header, and then a talk about interoperability testing regarding that. Two active internet drafts, the ICMP errors, additional ICMP code point errors, and the IPv6 router advertisement for the IPv4 unavailability flag, which I'll present, and then four new documents. The first one was something we asked to be presented here. It was also, you can see it's, well, in the file name, it's a v6 ops document, but it, depending on the direction it goes, it may make some standard recommendations, and so we wanted it discussed here. And then there's two documents from Fernando on temporary interface identifiers and an update to the ABIS document on the privacy extensions. And then lastly, proposal for an identifier for segment routing networks. Any comments on the agenda? Okay.
Okay, so let's quickly go through the document status. Since the last meeting, we published one RFC, that's 8319, on the maximum router lifetimes in RAs. We have one document at the ISG, which is the IANA options for DND flags field. I think that's on the telechat in beginning of April. We have one document in working group last call, which we'll talk about afterwards. That's the node requirements BIS document. And we have one active working group document, which is the segment routing header, which is also on the agenda for today. You looked very active there, Suresh. Are you jumping up to say something? No. So that was the documents we're currently working on. There are a few adjacent working groups who are working on documents that we would like you to take a look at. It's the Internet area has a fragmentation recommendations document that was also presented in V6 Ops this morning, but I will be in Int area just after this session. Go, Eric.
Yeah. Just want to say there is another document in Area, which is the provisioning domain document, which is heavily linked to IPv6. And that's my phone, sorry, so I cannot speak and shut it down at the same time. So that's also interesting to go to Area later today.
Okay. That was Eric Winke, by the way. There is a ILA document also in the Int area. In OPSEC, there are the two V6 filtering security recommendation documents. V6 Ops, there is route requirements and conditional RAs. And in segment routing, there's multiple documents, but probably the most relevant ones is the network programming one and the V6 use cases. Okay, I think that was all from us. Suresh.
Suresh Krishnan. And there's one more document. In IPWave, they finished the IPv6 over 8.11 OCB. So I would like to, so once they send it to me, I'm going to have to do like a 2-week class call on 6-man as well, just to make sure that things look okay. Because like one of the things when we did the recharter was like to see like, whenever something requires like review, like push it down here. So I want to just make sure 6-man gets a say in this document.
Okay, cool. Okay, then we have node requirements. Tim, please.
So what was this document you just talked about?
It's IPv6 over a new.
All right, hello, welcome to sunny London. Thank you. So I'm just going to talk a little bit about the updates we've made to 6434 BIS. I think at the last IETF, since the last IETF, we went through the working group last call. It was around that time. We had a number of comments, and this talk is just a little bit about the updates we've made as a result of that post-working group last call, and hopefully we're now ready to advance. So just a little bit on the history there. Started off out of observing that the previous node requirements document was 6 or 7 years old. Thought it'd be good to do a refresh. We've been through adoption through to the point now where we've got a version 7 that's a result of the working group last call, and we'd like to hopefully push this upwards. So the changes, just one slide here, just summarizing the changes we've made since IETF 100 and that working group last call. If you've got any comments to make on these, please come up to the microphone as I go along. It's just this one slide that we're summarizing things from. So the first one of those is that we synchronize some of the text in 6434 BIS to the text that's in 8200 and to some extent 8201, which are obviously the latest or the new versions of the V6 core spec. What happened there was, as we were doing 6434 BIS, 8200 was then being sort of crystallized into its final state, and we'd written some words in our BIS before they'd become finalized in 8200. So this is just about making those in sync. And I think it's largely in areas such as overlapping fragments, atomic fragments, defining new extension headers, and handling path MTU discovery. So everything 6434 BIS now matches up with 8200 and 8201. So hopefully that's okay with everyone. The next bit, we had some comments from people interested in network management about the management section. It still only says that network management protocols may be supported by nodes. That hasn't changed. What has changed is that we've just clarified out the things that should then be supported if you do network management. So the core, YANG modules, etc., that you would need to support. And we also, and it's in line with the router requirements document, added RESTconf alongside netconf. The next one was a clarification on unknown upper layer protocol processing. So there was something in 8200 that was talking about an unrecognized next header, and it wasn't clear as to whether that was an unknown ULP or an unknown extension header type. So we just add a little bit of text to clarify that you should do the same regardless of which case it actually is. The next bit, someone suggested adding this. This is the update to the multicast spec that basically takes some reserved bits and changes them into flag bits that can be used. So we said that should be supported. I think it was Brian Carpenter that made a comment about Type-C host behavior, so we've clarified that. The Type-C hosts in 4191, those are the ones that essentially maintain a routing table rather than just having a preference list. What's the next one? 7934, that's about the availability of multiple addresses per host. We just had some sort of woolly recommendation for that. We changed that into an uppercase should, which again aligns with the router requirement document. We had some additional IPsec text sent in. Remember that I think the IPsec text that we had included was still carried forward from the very first node requirement document, which is over 10 years old now. So we just had some more modern text inserted there. It's only a paragraph, but it was quite useful. We caught a reference to MLDV1 and replaced that with MLDV2. Node requirements is saying that MLDV2 is a must now to support, so we can support source-specific multicast. Next one. Yeah, RFC 7772, that talks about how nodes may behave if they're in a sort of power constrained mode or they're concerned about power consumption. So it says that if you're concerned about that, then you should support the things that are in this RFC. Previously, it only said in May, which was a little bit odd. And then the last thing was, I think Bob asked for us to do it, in the section where we described the changes from the 6434, rather than just saying what we've changed, we've also added a little bit to say why it was changed as well. Which also reminds me, we took out, again at Bob's suggestion, there was a bunch of email addresses of people I think that were acknowledged from the very first node requirements, and it's got a nice sort of flashback to how things were 12 years ago. People like Alan Durand at Sun, I don't know if Alan is in the room, there's all these people and where they were 12 years ago. Some are still where they were, but it's quite interesting. Anyway, we deleted all that. So it's got the names as acknowledgements, but no longer the interesting email addresses. So I think that's it. If everyone's happy with that, then I think we can turn to the chairs and ask whether we can advance it. I guess we can have a final check on the list, but I think we're okay.
Any further comments on that? Well, people are getting up to the mic. I had one question. Given this morning's discussion on the router requirements document, what would the consequence be if we took that text and reference out of this document? Would that be a possibility?
Sorry, is the question that we should cite that, or I think we cited it before and took it out.
Oh, you have already taken it out. Okay, since you were.
Oh, sorry. Okay, I've missed that. It says includes at the top. So yes, we had taken that out. Having said that, as I said in V6 Ops this morning, we also did quite recently against the requirements 01 document, router requirements 01, we did a sanity check. There were 7 or 8 things that were slightly inconsistent, and the authors discussed with Bob, and I think you were copied in, what we would do in response to that. And we fixed all of them by either updating what's in router requirements or in 6434 BIS, and I think they're largely captured there. And the only thing that's different is in the router requirements, it says routers must support DHCP-v6, and in here, hosts should support DHCP-v6. And actually, I'm quite happy with that combination. I think that is rough consensus.
Well, so remind me, so is it still referenced in this?
I think we've removed it, but hopefully Tim Winters is looking right now to come and help me. I think we removed it because it was clearly still going to take some time for that to go through. And as we heard this morning, it might even not happen at all.
Yeah, it seemed like it wasn't going anywhere.
Personally, I would like it to go through because I think it's a really well-written document, lots of interesting stuff.
Oh, sorry. Tim Winters. Tim Winters, UNHIOL. So we informally reference it. I don't think it would be a big deal to pull it out. It's in 2 spots. It's
okay.
informal. There's nothing.
Thanks, Tim. So I thought we had, okay.
Barbara Stark, I did look at the updates you made, and I think the draft looks really good.
Thanks, Barbara. I know you were concerned over the management bit, but
I looked it over. I like it.
we took your notes on board there.
Okay, well, good. So we will, I mean, it's completed working group
Right.
last call, and we wanted you to summarize the things here, but I think we're ready to start
Good.
working on the advancement to Suresh and the ISG.
Excellent. Thank you.
Thank you.
Super. Oh, yes. Okay, so Darren. This one is a bit loose, so. No, it should be one of these. I think so. Give it a try.
All right. Okay, hello everyone. I'm adjust the mic here. All right, Darren Dukes from Cisco, and we'll be presenting segment routing headers. IETF 6-band segment routing header version 10 is the latest version of that draft. We've got a fairly quick agenda to go through, and then open it up to questions and comments. We'll be giving a quick overview of some of the highlight content of the draft, although it's been around for a while, so I expect most folks here have read it, or those who are interested have read it. We'll go through stability of the draft, what's happened over the past year, some implementations that are documented, IPR content that the chair's asked to make sure was in there, and go into next steps. So, segment routing header is really defined in this definition here. There's a list of segments that get executed from the nth segment to the 0 segments. As we walk that list of segments, as the packet reaches each one of them, that next segment is put into the destination address of the IPv6 header. There's some flags and tags that are documented in the draft, and a list of optional TLVs. Hopefully that's familiar to everyone interested. The SR header defines a routing extension header of type 4. It defines the draft defines a data plane processing insofar as that it defines which nodes are responsible for adding the SR extension header and how that extension header gets processed at each of the destinations as that segment list gets executed. There's a set of definitions of ingress TLV, egress TLV, some opaque and padding TLVs, HMAC for securing the segment header itself, and finally a NSH TLV to carry a NSH option. Okay, so changes over the last year, there haven't been many. We've cleaned up the author lists, as has been requested by Bob and some other folks on the list, in order to allow this to progress. There's been some language changes in reference to RFC 8200 and how that's referenced in the draft. There's been a response to a technical issue on padding, which one of the implementers had brought up. We had an incorrect value in there that was fixed in the draft in version, I'm going to say version 9. And finally, we have running code that implements this draft since February 2017. Linux kernel 4.10 has a SRv6 implementation. Cisco, since April 2017 and onward, we've come out with 2 OSs and 3 ASICs that have implemented the SR extension header, both adding it and processing it at each of the end nodes. FDIO has a VPP implementation that's been available since April of 2017. You can grab that, and as someone reminded me, I'm going to put after this call, I'll put references to these implementations on the list so folks can click on them. Bell Canada Barefoot have demonstrated a P4 instance back in May of 2017, running SRv6 or SRH processing. There's this draft Fifi Spring SRv6 interop goes into detail on what these implementations are and what was demonstrated. I'll send that out to the list as well. And as the chairs had mentioned, draft VV Spring SRv6 network programming should be looked at by the folks in this working group to see what other content is in there. IPR disclosures, we've got a single IPR listing on Data Tracker. Folks interested can look at that. And that brings us to the next step, which over the past year, there's been very few updates to the draft. We have some working implementations. And so the question is to the chairs, do you think this draft is ready for last call? And can we make that decision?
Okay, so question from the room, Ron?
Yes, a response to the last call request. Time to make it.
Yes, I believe so.
Okay. While this draft has been stable for a few years, there's another draft, network programming, that has been evolving.
Mm-hmm.
This draft really can't be understood outside of the context of network programming. To look at this draft, the routing extension header is just for traffic engineering, IP address to IP address. Read through network programming and you find that it's actually for more than that. Read through network programming, you find some discontinuity, some internal inconsistency between the two drafts. You'd also find some things that might shock this working group. Things like instances where a single packet carries two routing extension headers. For this reason, well, initially on the list, I said we should either merge the drafts or last call them both together here. There's actually a third, more moderate option, which is to bring the significant information out of network programming into this draft, so the entire forwarding plane with the segment routing header could be understood. And then maybe it would be ready for last calling.
Okay, thanks. There was two pieces. Do you mind if I respond to that?
Yeah,
Good. All right. So there's two pieces that were called out specifically in that discussion on the list, section 3 and section 4 of the routing extension header, the network programming draft. Those sections are, I'd gone through them kind of side by side last night, and those sections are fairly completely described in, especially section 3 in the SRH draft. Section 4 defines the content of the SRH draft, defines the content that is in section 4 of draft FIFI network programming. And it limits it to 2 SID types, an AND and an N.EXID. However, the other SID types for other applications, we expect as those applications come out and use SRv6, there'll be other drafts that add additional behaviors and SID types as well. So I guess what I'm saying is the SRH draft defines the baseline enough to be able to implement a node that could add that SRH for the limited SID types that are defined and be able to process them at the midpoints.
I'd actually like to respectfully disagree with that. There are places in network programming where you'll see a SID being used the way an L3 VPN label would be used, or a VNNI, an EVPN, where it's actually talking about pop the IP header and forward an Ethernet frame. Those sort of things would be shocking.
Well, that's what a destination address does today, for example, in an IP tunnel. And that's the last SID in the list. That's the destination address of the list, of the SID list.
I'm not quite
and
sure.
that behavior is I don't think is new to anyone who's implemented L3 VPNs.
I'm not quite sure I'd agree that that's what routing extension headers think they're for, but anyhow.
That's what the SIDs do.
Okay, Suresh Krishnan. So the other thing that, Ron talked about, it's in the other draft, is the insertion stuff, right? And one of the things we talked about in 6-man a while ago was that the author set of this thing would write another document describing safe header insertion. Okay, that document has not been updated for a while, right? Okay, so do you have a plan for updating the other document explaining the safe header insertion? Because I'll tell you what's going to happen. If that doesn't happen, and if the other draft from routing hits the IESG, I'm going to hold a discuss on it indefinitely.
Absolutely.
Okay, so I want this work to be done, and I don't want to serialize the work. So I want this work to pick up right now, so that before the other draft hits the IESG, I want to see the safe stuff. So it can pass, right?
So
I'm concerned at the speed. So I would really like implore you to like, put some effort on that and get that out of the way, because like otherwise, like, people are going to just come up and tell you all the time that that needs to get done, right?
Yeah.
So, and I'm personally fine with like, this going to last call. All Ron's comments aside, like maybe we can, like I can push the document here for review, right? Like whenever it hits IETF last call, I can push it here
Right.
and get review on it. Like we've done this kind of stuff before, so I'm not necessarily getting on a last call for that to this working group.
Okay.
But I'll make sure that 6-man sees this, and I'm going to see it, and
Yeah, absolutely.
everybody's going to see it. Okay, it's
Yeah.
not going to go anywhere.
Yeah,
But I
that's
really
an-
want you to spend cycles on describing the header insertion.
Yeah.
Okay, so that's like draft warrior,
Mhm.
6-man header insertion
Yeah.
for the people who don't know about the draft. So I really want that progressed. Okay.
Excellent.
Yeah, thanks.
Understood.
This is Zafar. The point I want to raise is that Ron's comment and the other comment are on different draft, not on this draft. And if you take analogy for the MPLS data plane, labels were defined and we're still using and defining those usage of that labels later. And with the split of working code and interop, there's also another presentation that talks about interop that happened recently as well, along with all these interops. I think we are ready. This has been stable for a long time. We have enough working code, and we can define other like the network programming uses of this draft in other cases like L3VPN and other use cases separately, and they will be reviewed. They will be reviewed here as well as Spring, and same with Draft Warrior. They will be reviewed here. Yeah, absolutely.
Yeah.
We're on the
Okay.
same page.
Following up on the last comments. First, I think it might be a synthesis of what you just said. The minimum requirement for this document is to describe the entire SRv6 forwarding plane, not necessarily every instruction.
Mhm.
Instructions are going to be invented for years and years to come.
Yeah.
But enough so you understand how the forwarding plane works.
Mhm.
Insertion's part of it. There's some importing, there's some heavy lifting to do. I'd even offer some clock cycles to generate text for you. I'm supportive of the work. I just think it should be a good document when it comes out.
Right. And I think those who are implementing, as you're implementing, we've gotten some feedback from folks who have implemented and given it directly to the authors. So, I mean, if you're implementing now, certainly come up with those things that are that you see as blocking you from implementing this specification well, and let's kill them. Let's get them done. Absolutely.
This is Zhenbin from Huawei. I want to add the additional information. In fact, we also implemented the SRv6 features. I think that there are already several SRv6 implementation in the industry, and the interoperability test is prepared and is being carried on. So I think this is the adoption, the last core of the draft. It will set up a baseline is for the interoperability test. So we support this, the last core of this draft.
Okay.
Yeah, thank you.
Suresh Krishnan, completely unrelated thing. Like
Mhm.
you talked about tracking the implementations, right? So
Yeah.
instead of like putting it on the list, there's an RFC that describes like implementation status section for the drafts. So what you can do is like you can add that. I think it's like 7942. It's 7*42. I think it's 7942. So you can add the section. It says like, okay, there's a Cisco implementation, da da da. You can put all those things in there,
Okay.
and the thing is published as RFC. It gets removed. So like until then, you can track the
Okay.
implementations on that.
Perfect.
So just like follow that thing. It becomes easier because everybody knows where to look.
Right, then
Because
we
if
don't
it
have
hits
to
like
jump to a
people outside
second
the
draft.
working group, they can see too.
Okay. Good. Thanks.
Yeah, one other thing I would noted is, which relates to some of these, is there are no normative references in the document to any of the related work. They're all informational, and I suspect that's not correct.
No. Yeah. Let me look at that. Let me.
Yeah,
go
because
back
it
through
clearly
that.
is dependent on the
Yes.
several of them. So
It is.
that's going to, I mean, I don't think that can be fixed without, we could still do a working group last call, but
Yeah.
that will need to be resolved.
Yeah.
Pardon?
Exactly. Yeah. It's yeah.
Right.
I can
That's an
throw in
easy-
an 11 with them fixed.
That's an easy fix.
Okay. Any more questions or comments?
I think just one general comment from my perspective, with regarding to what Ron said, I think the more, the smaller and more core and more baseline or the mechanism can be in this document with the fewer dependencies on, that networking programming, I guess
Right.
is still an individual draft, right? The easier I think this is to serialize and progress quicker.
Okay, that's good advice. And yeah, we can certainly talk about what that means as far as the next version of the draft and how that moves.
Is there one more
advice.
comment? No, that was Jean May not going. Okay, super. Thank you.
Okay, so what's the, do we have a disposition or what's the next step then?
I guess I think there's going to be issues, but working group last call is not the end. It's
Yeah,
sort
absolutely.
of formally asking the question. So I think I'm comfortable with us starting this up pretty soon.
Okay, great. Thanks, guys.
Thank you. Okay, so we'll continue on segment routing. Is Carsten? Are you doing the presentation? If we have no one jumping up and wanting to do the presentation, then I skip. Yes, I think so. Going once, twice. No one wanting to own this one. Okay. It was, yeah. Okay. Then we have Tom Herbert for ICMP errors. You now have plenty of time. And you have to sign anything. Yes, thank you.
Hi, so my name is Tom Herbert. I'm going to talk about some proposed ICMP error code points. So one thing we've noticed is that middle boxes in host occasionally drop packets because headers are too big or for various processing limits. And this happens a lot with extension headers, as we know. And so we're seeing the problem manifest itself in extension headers. So the proposal is some new ICMP errors to basically signal when this happens. And the goal of this is to increase visibility into what these devices are doing when they're dropping packets because of they're hitting processing limits. And hopefully with the feedback, we may, at the source, be able to modify behavior to kind of avoid the problem in the future. So the actual problem, real devices have limitations. So some of these are kind of hard limitations. For instance, some routers have a parsing buffer, say 256 bytes. If the headers they need to look at go beyond that, they're kind of out of luck. Either they need to go to slow path or drop the packet. It's also a case that unbounded list of headers can be denial of service attacks. So we actually recommended in 6434 bis to put some limits on host processing and extension headers to avoid denial of service. And that gets us into, this is both a host and an intermediate node problem. So there are cases where either of them may drop packets because of extension headers, because the header's too long. Even though this is might be non-conformant, it is kind of reality in some situations. So the effects of the drop, source has no idea why their packets are being dropped. So this kind of leads us to no visibility. We don't know what's happening. Without the feedback, can't fix the problem. Middle boxes, it's in a sense too easy to drop packets without incurring any cost. So the net result of this is, in the case of extension headers, it's just easier not to use them. But as we see with segment routing and some other proposals, we do want to use extension headers. So this becomes more of an immediate problem to solve, I think. So the proposal is some new ICMP errors, and these can be sent by host and middle boxes. Now I would note they are ICMP errors. So all the normal caveats of ICMP errors being generated, blocked, those should apply. As well, the security considerations should be very similar to the normal ICMP errors. The idea is that the source, when it gets such an error, at least can log it, if not, take corrective action. So the proposal is modify or introduce 4 parameter problems. Code 1 is unrecognized header type. This actually exists. The idea here is that intermediate nodes could also send this. So for instance, if an intermediate node needs to parse into transport layer to do a firewall, look at ports for instance, and if it doesn't recognize the headers to be able to do that, it could send this if it has to drop the packet for that reason. So this could be distinguishable from the normal use case where a net host is sending this message based on the IP address of the source IP address of the ICMP error. If it matches the destination of the original packet, then it's a source, or the destination actually sending the error. Otherwise, it would be a middle box. Code point number 4 is extension header too big. So this is a single extension header which just has an enormous size, and the device can't process that. Extension header chain too long, it's kind of similar, but in this case it refers to the whole chain. And there's two possibilities here. One is the chain is too long in terms of number of extension headers, and the other one is the aggregate length of the chain is too long. So we allow for both of those. It should be fairly obvious from the pointer which one of those two it is. And code point 6 is too many options in extension headers, so this applies to destination options or hop by hop options. This is when the count of options gets too big. We also define one ICMP destination unreachable. So this is for headers too long, and this is a little more generic, meaning the full list of headers, not necessarily just IP, but other headers, was too long for the node to process, so it sends this error back. This needs to be a destination unreachable because it's not a parameter problem. It does not necessarily apply to the IP header. So given all these errors, we can define a reporting priority. The priority basically goes from existing ICMP errors, unrecognized next header type, too many options, extension header too big, and then the header chain too long for number of headers, header chain too long for number of bytes, and then just headers too long. So trying to go from most specific to least specific. So the idea is if multiple errors apply in the same packet, the node should send the one that's gives the most specific error message. In most cases, we're using the ICMP error pointer to point to kind of the offending byte. In the case that the length is too long in terms of number of bytes, it points to the first byte after the maximum that would have been allowed. If it's in the case of something like options where there's too many options, it points to the first byte of the option beyond the number of options that would be allowed. So for parameter problems, this is actually just the pointer field. For the destination unreachable, we use the multi-part ICMP message, and then the pointer becomes part of the data after the embedded packet. So the question is always, what is the host going to do with this? So first thing, at least log it. So we get this logging information. This is an error back to the administrator. When somebody goes to debug the problem, at least they have this information, and maybe offline can rectify this situation by not sending the extension headers. Maybe in the longer term, we report this error to the application. So the application may be able to take action. One thing we foresee in some use cases of extension headers is to do something like happy eyeballs for extension headers, where we try different variants, and when something goes through, consider that a success. But if it doesn't, back off, maybe try to use fewer extension headers, try to find the right combination. So if we have this feedback coming in, it actually would expedite that process of narrowing down what the acceptable list of extension headers, for instance, are. That will require some new API. So, but I think basically for using extension headers, we're probably going to need, in mass, we're probably going to need some new API anyway. But we do need some API to report back to the host these sort of errors. We could also adjust path characteristics. So if we figure out that there is a problem on a path as opposed to just a particular host, we may be able to set that. And then when a new application comes up, it can get these path characteristics and maybe not go immediately to using too many extension headers or something of that nature. So that's all I had. Any questions?
Darren Duke, Cisco Systems. Tim, when you say you point to the extension header or the byte past the thing that would be offending or that was too long, how does that work for, if I want to be generating this error out of an ASIC, for example, and I only get to look at the first 200 and some bytes or whatever of this packet? How do I point to the next thing that I couldn't get to know where that next thing is?
For an encapsulation, you mean? Or?
Well, so if I'm processing this packet and I need to get into the transport layer, but I can't get past the extension headers because there's too many of them or they're too long, but I want to generate one of these errors back to the source. Now, I can't look past so many bytes because I only get so much space in that ASIC to look. I could punt it and have the RP deal with that. But I wonder if you could maybe think of a more hardware-friendly way of generating these errors so that you don't have to look past the part that you can't get to.
Well, I mean, what I guess the question is, what would happen in the hardware? It would see that it's at its limit, right, at some point.
That's right.
And where the farther it's extended got, I would assume that's as far as it can go, and maybe the pointer becomes 1 byte after that.
Yeah, except in the case where you're saying the point to the next extension header beyond the number of extension headers you're able to get to. I see.
So
I can't get to the next extension.
Right. So you don't want to parse into that.
Yeah, exactly. I can ask this on the list maybe, and I don't want you to answer it right now, but
that's a good
put it
point.
on the list.
So clearly we should point to something after the bytes that you're able to parse.
Yeah. It may be a recommendation. But.
I mean, conceptually, you could determine the length of the last extension header, but that's probably not what you're looking for. Okay.
And I'll send it on the email list and see what thoughts
So the point is taken. I think it would be nice to be able to distinguish those cases with the pointer. I personally, I prefer not to have another error just to distinguish length versus count limits.
Yeah, so Krishnan. So Darren, just to answer like one thing, right? So 40, the ICMPv6 RFC, right, requires you to stuff as much of the packet as you can until you hit the MTU, right? So like that part needs to happen. So like even if you don't necessarily have access to it in the ASIC, like your slow path like needs to still fill the packet until the MTU. So maybe like you can push this down to the slow path processing, like if you want to do that. Like so that could be an option, because like I don't want the 44, 43 musts relaxed in this document. Okay.
So I do have a question. So what would you recommend for the next steps? Do you think this should be a working group item?
Well, so let me just first make a comment. So I guess I'm somewhat skeptical that hosts are going to be able to make any real use of this. I mean, it's like extension headers get added, they may get added in the application, they may get added down further in the IP stack. So you haven't convinced me that their hosts are going to be able to make any use of these extra code points.
So consider host setting and destination option, and that would come probably from the application setting destination option. This is what we intend to do in FAST, for instance, where we're attaching service tickets. So the problem we have with extension headers is they're not reliable, right? So we know that they're dropped often in the internet. So anything we can do to facilitate their use would be good. So we are going to be in situations where I want to use extension headers on the internet, and I'm going to try to use them. And if they don't work, I'm going to have to back off. I can't just say the application dies. So we have to have that sort of back off. So really it's a question, how do you implement a back off when extension headers fail in a path?
Right, and you would like to get feedback.
So the feedback is one part of that. So regardless of the feedback, the problem doesn't go away, right? I still want to use extension headers. And obviously, since this is ICMP, that's unreliable in itself. So we're not always going to get the feedback. But what I'm hoping is this could be a way to expedite that loop to shorten the length of time. Otherwise, I have to do a whole bunch of probing and things like that to try to find the magical extension header. So for instance, if it really is a case where a device is dropping it because it's too long versus if it was shorter, they would have allowed the extension header. How do I quickly get to that that point. Because I may end up setting, say, 3 extension headers. Maybe one of them I really need. What if I didn't need the other 2? So I guess what I'm looking for here is some flexibility in it and be able to use extension headers.
Well,
I think it's a trade-off.
Understood. Yeah. Just, and then there's the question of whether the boxes that, because I think you're really talking about intermediate boxes, not I mean, the destination host doesn't usually have a problem with this. And so are those boxes going to actually implement any of this in?
So obviously, hosts are more likely to have implemented extension headers. I would agree with that. But I think there are, my feeling is we haven't deployed extension headers to the extent we really know how they're going to work in mass. And anything we can do to assist that, I think would help. So maybe hosts won't have a problem with this, but as we pointed out, we already have limitations on hosts to handle denial of service attacks. So if you remember that discussion, without that, extension headers would be a pretty big pain.
So just so Ole Tran standing there, just to follow up on what Bob said, I mean, do we have with existing host implementations, do we have any good knowledge about what they do with the existing ICMP errors? I'm kind of asking about the granularity you need. I mean, would it suffice if you just got parameter problem, for example? I mean, if hosts don't do anything with them anyway today, and I don't know, I'm not a host.
Well, I mean, they process them, right? I mean, packet too big is definitely processed. As for parameter problems, the most likely thing is they would log it. And a parameter problem today would more likely indicate an actual error as opposed to a limit. So there is a little bit difference there. What I think we would need is, it should be a fairly simple API to send the error back up to the application. Or in the case, if the options are actually set, for instance, in a socket, then we could actually do all that within the stack.
But it's you need quite a sort of big ecosystem here to succeed with this, right? You need implementations across the whole spectrum, and you need probably, well, improvements in the APIs to be able to do it. So it's,
we need to change the world. I mean, how many times does that happen? How do you change the world? We need to start somewhere. I think maybe you might have a good point. We could implement something and demonstrate it. That might have some value.
Michael Abrahamson. So this is when something couldn't process all the headers, and it said, I'm not going to allow it unless I can process it, right? That's what these errors are all about, right?
Yes, it is I want to do it, but I can't. It's
right.
not being prohibited by policy.
So it struck me, do we have a header not allowed error, like a port unreachable? Is there, like, if I want to filter shim6 extension headers, I don't want to allow any of those packets. Is there a way to tell the host, no, you don't get to send shim6 extension headers included?
The network does not filter packets in 6man.
Okay, so in the real world, do we actually have an error for this? Like, or if the destination, like, is there an error for that?
So there's question, like, I think it's parameter problem.
Can you specify which header was not allowed? So I get,
but this is a
Pointer to the error.
Okay,
It doesn't know what, like, you need to figure out what it is. Like, it just didn't know what it is.
So you,
At 12, there was something I didn't like.
oh, okay, so you can identify which header was the problem with that.
If you wrote code, yes, but nobody has this code.
that's a middle box.
From a protocol point of view, it's possible to code that with the existing standards.
So there's question. So just like, paraphrasing Lorenzo or channeling him, right? So the side that didn't understand it. So it doesn't know it's a shim6 error. So it says like this, like location in the packet where I saw this shim6 header, I didn't know what it was.
So I changed the subject. I said, so I'm not talking about unknown. I'm talking about if I have a firewall that doesn't allow shim6 extension header packets, can it signal to the sender to say, this specific extension header, I'm not going to allow? Like, I can tell it, I filtered this because of the destination TCP port. That's why, that's why I dropped it. But do we actually have a way to signal this for headers? Do we need it?
There's a policy problem. Could that be used?
Yeah, but can you tell exactly what policy was violated? There was headers and not something else, the protocol number or something? Okay, never mind, next in line.
Mike Ackerman, a different perspective perhaps. I'm from one of those horrible enterprises that's resistant to V6 deployment. One of our excuses is the lack of network management information, and error information. I think this would go a long way, so I think this is good work and would like to endorse it. We also don't have extension headers and we'd like to use them. And one of the reasons we don't use them is when we have problems with them, we won't know why. And I think this would address that. So.
Good point.
Thank you.
Ron Bonica, Juniper Networks. Oli has a good point that sending a parameter problem message to a host may not be enlightening. I go to a website, it doesn't work. I'm not going to go look at ICMP. I'm going to go to a different website. But this might be helpful when the source is a tunnel ingress node. Then if everything going through a tunnel black holes, somebody might look at a log to figure out who it was that was complaining about not being able to pass extension headers. So there might be a good use case.
Yeah. Well.
Yeah. Okay, so why don't we do this? Why don't we do a hum for adoption here? Does that sound fine with you, Tom?
Is there anything you'd like to see in terms of discussion?
Right.
Thing at a time.
Yes, let's see if there is support in the working group to adopt the document as a working group document.
Okay, thank you.
So the people who are in favor of adopting this document in 6-man, can you please hum now? Okay, and the people who are against adopting this document, please hum now. Okay, excellent. So we'll confirm that on the mailing list, and we'll let the authors know when and if they can submit a working group version of the document. Thank you. Oops. So, Bob, you next. Stand in the pink box.
And I hope you notice you can either take my picture or not take my picture. So I saw Jen doing this first, so I liked it. Let's see if the next slide is. Yeah, so this came about based on a discussion we had at the last IETF on the IPv6 only network. We noticed that dual stack hosts, which I think are most hosts these days, we're still trying to use IPv4. They're creating addresses, they're attempting to reach services, and it wasn't a giant amount of traffic, but it was some traffic. And so there was sort of this discussion on the V6 list about this. And so I ended up with Brian Carpenter writing a draft to try to build a mechanism to maybe that we could do tell the host in the right circumstances that there is no V4 here and you don't need, you can stop trying to do that. And so the behaviors we noticed were, we see a lot of layer 2 broadcast traffic. V4, of course, just uses broadcast. You see ARP, so it wakes up every node on the LAN, on the link will receive this stuff. This causes drain in battery life for devices that aren't plugged in, and then possibly could, if you were intending to run V6 only, it could possibly allow IPv4 as a back channel for things the administrator may not be looking at. So the proposal is fairly simple. It's just to use one of the reserved flags in the router advertisement. I call it the we call it the IPv4 is unavailable flag. And the values are 0 is the current state, assumption that IPv4 is available. And this is compatible with, and hosts that don't implement this, the neighbor discovery already says, don't just ignore flags that you don't know about. So it doesn't, keeping 0 as sort of current state doesn't break anything. And then 1 means that the router is asserting that it has no v4. So, there are 2 values. And the draft would update the IANA registry, appropriate IANA registry to define this flag. So there are the router configurations, this is only should be done on a default router. There are other kinds of router-like devices that, don't route traffic, but still want to send advertisements. So hosts will only process this if it's a default router. And the notion is that the administrator sets this flag. It's not something that the router sort of decides on its own. So, so if the people, organization running the network are want to run v6 only, they can use this as a tool of telling the dual stack host to not attempt to use v4. Host configurations, again, the hosts only look at this if it's a default router, that is, if the lifetime field is not 0. If all RAs received have the flag set to 1, then the host should not attempt IPv4 operations. It's reasonable to assume there's no IPv4 on the link. And, counter to that, if you receive any flags with 0, you continue with v4. And this avoids a lot of problems that, it's hard to use it maliciously because the other routers will still be advertising with 0 if there was v4. It's advisory. The host really would get to decide what they want to do. Other choice, the host may decide to delay v4 operations until they've received RAs, or they may only want to do v4 if they actually have an application that requests it. This is the time for discussion, but the authors are basically asking, is the working group interested in adopting this? So questions?
Michael A. Ramsey, you said administratively set this.
Yes.
Is that actually in the document stating
that? That is currently in the document.
Okay.
It was not in it's in the latest draft. It's not in the previous draft.
Right, because if let's say that the upstream is a PPPoE session and it is v6 only, and the router discovers this, is it okay for it to set it if that condition is that administrative, or is that not allowed by this document?
Ask that again.
Okay, so the router has no v4 connectivity upstream,
right?
And so it doesn't configure itself any v4. Is it okay to set this flag then? Because it's not administrative set by person. It's discovered that this is the condition it's in. Home gateway, PPPoE session, v6 only on the PPPoE session.
So I think so, but I'm not sure.
Okay.
Hello, Julius Krobacek. He finds my name complicated. No, it isn't. Come on. I have 2 questions, one which I'm not asking and one which I'm going to ask. So the question I'm not asking is, why doesn't that happen over DHCP v4? But I'm not asking this question. And the question I'm asking is, why is it a flag rather than an option? And the reason for that is that I can see 3 values for that. One is, this router makes no claims about whether there is any DHCP v4 because I'm an IPv6 router and I know nothing about IPv4. This router claims there is IPv4, and you should do some DHCP-v4 if you wish. And this router is strongly convinced that IPv4 is obsolete. And so the first option would be the option is not present. The second one, the option has value 0 or 1. And the other one would be the opposite version of the option.
So let me just turn that into a question to you. So what would you expect the host to do differently based on those three values? I mean, I certainly
envisioning
agree. I do agree if it's not just a two, A or B choice, we should use an option and not a flag, but using two flags wouldn't make sense.
Options consume a minimum of 8 bytes, I think.
So it's because you want your arrays to remain small that this is a flag rather than an option?
Well, no, but my real question is, what is the additional state? What would the host do with those three different settings as opposed to just V4? There is V4, there's not V4.
I'm envisioning a future in which by default networks have no IPv4. And in this future, it would be weird to remain forever with a flag set to 1 saying don't use NetBIOS. Compare this to current situation. Suppose there is in every single router advertisement packet a bit that is set to 1 to say do not speak this protocol that has been obsolete for 20 years. How are we going to explain to our grandchildren what is this one doing in the router advertisements?
Well, so I was actually asked that by email earlier today too, and I gave two answers. One was, it's good to remember our history. So if this is the only remnant of V4, then that's not so bad. But the other thing too is, 20 years from now, when people have forgotten what V4 is, we can probably reclaim the flag and use it for something else.
That never happens.
No, but it would be, I think, a very small problem. If this is the problem we have after getting rid of V4, then it's not so bad.
So declare it to default true. Implementations declare that they would have seen this. Oh. Lorenzo, I think so. I sympathize with the problem, and I think we need to solve it. But every solution that's been here that has been proposed so far has been suffering like the death of 1,000 cuts. And I was like, what if there's 3 routers that don't agree? Like, what happens on this case? What happens in that case? If we can solve those problems, great. If we basically just become mired in discussion, then one suggestion I would want to offer would be to say, look, this is a hint, because my implementation,
It does actually say that in the draft.
But it also specifies what to do, and therein lies the potential for disagreement and thus endless lack of progress. So what I would suggest is we could cop out entirely and say, we don't know what to do, but there's a hint that there's no V4. And what I can do is I can change my exponential backoff timer from capped at 2 minutes to capped at 2 hours. And I saved a lot of power like that. He can do something different, and whatever, Dave can do something different. And I think, at least we can publish something. So like I said, generally we talk about working on a problem as opposed to working on a specific incarnation of a draft or solution. I think this problem is important, useful to solve. And if we can't stop disagreeing on it, let's just cop out and say, look, this is just a hint, do whatever you want with it.
In some, I think you're correct. It's going to depend a lot on what the hosts actually decide to do with this.
It doesn't matter. That's my point. If we disagree on that, we can just say it's out of spec. Does anybody disagree? No, but there's a definition of what it means, right? And we've been disagreeing on this for multiple IETFs. It used to be in Sunset Forum we couldn't agree on it, right? Anyway.
It's so much easier. We love to have disagreements over single bits too.
Suresh, did you want to interject something? Or
So AD override, Suresh Krishnan. So like one thing I don't want to happen here is like sunset 4 over again. So I think it's an interesting problem to solve, but I'm not sure if it should be solved here. So that's like really my comment. And so I'll let other people talk and then I'll get back in line after.
Hi, so I have a production Pi hosting infrastructure.
please.
Oh, Pete Stevens, Mythic Beast. And we DHCP a little bit of RFC 1918 space, so you can get to the file server. And everything else comes from V6, where you see a router over a route announcement. If you send me a 0 in that bit, you are asserting that my file server will give you global V4 connectivity through your RFC 1918 space, which is not true. If you write 1 in that bit, you are telling me I should not make any V4 connections and disconnect my file server, which is very unhelpful. So I don't think that that bit can mean what it means. I don't think V6 routers should be able to state that other things on the network do or do not provide V4. And similarly, the converse is my V6 router should not be able to say something else provides V4, which may be providing V4. Or similarly, it should not say that I am providing, it should not say I'm providing V4 if I'm not. So yeah, I don't think the binary state can work in a case where you may see a tiny amount of local V4 traffic, but not global.
Okay, but I would argue that what this is trying to do is to tell the host whether to actually like enable its V4 stack. And in your case, you wouldn't want to set the bit because you're going to still be using V4. The fact that it's local versus global, I don't think matters.
So if the bit is set, that says I have V4 connectivity. Sorry, if the bit is not set, I have V4 connectivity.
Well, it's really, it's all it's really asserting is that it's not saying anything about V4. The other setting it to 1 says the router thinks there is no V4.
Right.
Leaving it at 0 is whatever today is.
Lee Howard, I thought that my understanding was that it only says I am not a default gateway for IPv4. There may be others, right? Isn't that what you just said? That's what so he said. I thought Pete's assertion was that the flag being set means there is no IPv4 on this network. And right, but I thought that what Bob said, no, that's not what Pete said. That's okay, right. But that's not what the draft says. What the draft says is this router that is issuing this this packet is not a default gateway for IPv4, which means there may be others in the network, such as your IPv4 default gateway. I think you're. Well, so then you would not set this bit because the same router is providing both V4 and V6. There's just DHCP. Okay. For the local, thank you for the local network. Okay, I misunderstood that. But it's also that router is therefore not a default gateway. So the host, so if it gets DHCP v4, that may be a good disambiguation then.
Peter, you might want to come back up again and you can talk to Lee.
There's no default route for V4. So should I set a 1 in my router announcement?
So this basically means, I think it was already stated, if this is 1, you may opt to not start your V4 stack at all.
No.
You may.
It says IPv4 is not available on this default
Yes.
router. That's what the text of the draft says.
So we may need to refine the language to say that if you see other hints implying that there is IPv4, such as you have also sent a DHCP v4 request and received a response. Maybe that's an alternate hint. But it's also, in your case, I still say you probably wouldn't want to set this because if you're not sure what the host behavior is, and since it is administratively set, it's set by the administrator,
yes,
then it's of course your choice because it's your network.
Yeah, you would just leave it as 0.
Now that I understand, I think that there's useful clarification to be made there.
Oh, I'm sure the document could be improved.
So I did want to say that I do think that this solves problems that I have because I'm struggling to, when doing V6 only testing, I'm struggling to get V4 not there anymore. I I did want, actually, I think Suresh already addressed another point that, let's make sure that, I think Sunset 4 is still technically open. Let's check with them. As for whether it's set by the administrator, so I just said, hey, don't set it because it's set by the administrator. I'm pretty sure that even if router vendor doesn't say, hey, I have no v4 on any interface, or somebody typed no IP routing, or there's all of IPv4 has been manually turned off, that I might not also need to manually set the bit. That's a UI problem. Even if all of that logic doesn't exist, I am probably still going to script things so that it's done automatically anyway, because I want the dynamism there. So, but I guess that's the same thing as being manually set. It's just automatically.
Right. That's your way of doing that.
Yeah, Jelinkova. So I think it's a good problem to solve, right? What I was a bit confused when I was reading the document, we given some ideas to the host implementers what to do, right? We're not prescribing any behavior. Okay, network might give you a hint there is no v4, and you're saying host might choose not to start v4 stack. Does it include it would not configure link local v4 addresses, or it's just not trying to do the HCP? It might be.
No,
in the list of the ideas what to do, we might say explicitly don't even configure any v4 addresses because it might be undesirable in this
Right.
case.
I mean, I interpret it as not creating any v4 addresses. Don't ARP for them. Don't do any. Yeah.
Because I think currently if host just doesn't get DHCP, it might still configure link local v4. So it's like if I disable v4, DHCP v4 on my interface, I assume it will get configured link local, and we might probably. Yeah, so it might be just another hint in the documentation what to do.
We deleted that actually. Sorry. We deleted that before.
Still on. Barbara Stark. I think the draft is useful. I think the bit is useful. I think it does no harm, and I think it may do good. And in that context, it may be useful.
David Skenazy, Apple. I'm actually gonna, or not necessarily disagree with the people before me, but ask for a clarification. What problem are you trying to solve? I'm kind of failing to understand the theory. Can you give me an example of a network where you would do this? Like my home, an enterprise? Well, this one. So the IETF network. Well, no, the IETF NAT64 is a test network. I don't see that as a good example, sorry. I use it, I have all my devices on it, but give me an example of a device that regular people. So it would be the primary IETF network, okay.
Well, I mean, if on my home network at home, I decide to run v6 only with a NAT64 at the edge, then I would assert this bit as the administrator.
Okay.
Because I don't want any v4 broadcast traffic.
But so let's say that theoretically, I make client devices, and
I've heard of that.
And I have them on my home network. The home network is configured this way. I also have a very old printer from a different manufacturer that's v4 only. I still want to talk to that device. So even if you set this bit as a client device implementer, I'm still going to do v4 link local. I'm still going to do MDNS bonjour over link local, and I don't feel like those problems aren't solved anymore.
Then you shouldn't set the bit. If you have devices that can't work in v6 only and you're the administrator, don't set the bit.
Well, in home networks, there is no administrator. Like you're not going to tell people to go set that bit. Then what's the point of it? I'm still failing to see a network where this adds value. It's all right, sorry, I'm missing something here. I'm not saying you're wrong.
Veronica McKillop, Microsoft IT. I might actually see the point, and for me, this would be a welcome solution. So I'm in a process of turning our corporate network to IPv6 only. That's for 220,000 users, over 1.5 million devices. And I've got a problem that not all the operating systems on the network are reacting the right way. So yes, there are the self-configured IPv4 addresses, And there are services that are trying to do work over v4, even though I'm giving them only v6. So if there is a way that the network could instruct the endpoints that they should not even attempt v4, that would probably make it easier for me rather than waiting for all the OS vendors, and I'm talking even my own house, actually deploying certain behavior which would deprecate v4 behavior on the host. So I'm an enterprise and I want this.
Good, thank you. I mean,
Thanks.
that's.
I
that's
totally
the
buy
intent.
that use case, by the way. That I totally see. Thank you.
And we've tried to design it such that, I mean, if there are old hosts that don't process it, or they're v4 only, it's not going to stop them from doing anything, but all the hosts that do understand it will stop doing v4, and it'll lower your background traffic.
Django, another use case again, yeah, for example, enterprise network, right, which is moving to v6 only, and we do not want to care about v4 anymore. It also potentially protects me from accidentally someone turning DHCP v4 server on the network. Because if all my hosts mostly by default ignore v4, right, and I can tell them that, I hate having all these complicated features on the switches, right? This is an additional thing, right? Protecting me with one line configuration on the router instead of all this additional stuff on switches. It minimizes the risk. Okay, it's not fully protect me, it minimizes the risk. If I can ensure that all my hosts support this feature, for example, in a controlled environment, it's much easier for me to okay, great.
Okay, good. Suresh.
Suresh, did you want to say something?
I just wanted to ask you something as well, Suresh.
I already said what I wanted to say. Like, I think Sunset 4 might be a better venue for this. Like, and I'm open to this, right? Like doing this here, but I think they might have a history of like, what are the things that kind of came up before, or maybe I think like a lot of the same culprits are involved in all of these things. But I think that might be a useful thing. I can just talk to Terry a little bit and see like, how we want to do this. I'm personally like supportive of this work going forward, right? Like I just have like no direct position on where. I do think like Sunset 4 might be a better venue, but there's not many people left there. So like that's like something we had to weigh somewhere. But personally, go ahead, do the call, and we'll figure out like what to do after.
Well, we could certainly do a hum if there is support to adopt it in some working group that might not be 6-man.
Do the adoption call in 6-man. If you have to move, we move. Like we moved like I think like
Right,
GUI from like routing area like NVO3 to int area. So like we can do this thing
Right.
after. Like we can figure it out. But like yeah, that is my personal view. Like would be like that would be a better venue. But if there's nobody to review stuff there, then we'll do it here. Right? Like that's my goal, to have the right set of people to review the thing.
I'm not sure you have a personal view given your AD hat in this working group, but
No, but I did say personal view. That means my AD hat was off, and I said the last thing.
One last comment.
I got a question. Isn't there also quite a risk in that on a perfectly well working IPv4 only network with a lot of IPv4 hosts and this standard being adopted by a lot of the end hosts, somebody suddenly announces no more IPv4 and the whole thing just dies?
Suresh Krishnan. So like that doesn't that's not dictated by this draft, right? This draft only says I don't know about this. It doesn't say IPv4 does not live here. Like that's a different draft in Sunset 4 that had different semantics. So like if hosts end up doing that, that's too bad. But that's not what this prescribes if you read the draft.
If I understand it correctly, it says, well, there is no IPv4 on it, so
and all a host has, if the host gets any RA with the flag to 0, it will continue with v4. So just some random node sending an RA with it set will not cause the switch.
But I think his point is that you have a v4 only link. There's no correlation that a host makes between a v4 router and a v6 router. Suddenly someone just puts a v6 router on that link. That's the only one, and it's going to set that bit. And that means that all the nodes that are there already will disable v4, right? Because there's nothing else to tell you the 0 bit.
For what it's worth, this is what killed the proposal in Sunset 4. Yeah.
Yeah.
Right. So just, I would say, make it a hint.
Yeah, well, it does say that, I believe.
I think it's,
But I'm very open to send text.
So if I again understand Lorenzo correctly, he's saying like don't describe any behavior on what to do. So take out all the text which says like host can do da 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 with it. Just say like this bit says this router is not a v4 default router, and that's it. That's what he's suggesting, if I understand him correctly. That's it.
Bjorn, I think you want an extra bit. You want to say, if this is set, do not speak any before and turn it off for real. And then you want the parenthesis and say, do not use this option, because that's what they're discussing.
Okay, and we have one from Michiko. Fernando, please.
Yeah.
When you
What I wanted to know is that, I mean, if you do specify this bit, you have to tell nodes what to do. I mean, otherwise it's actually even more of a problem because now you have a behavior, or you're signaling something to the nodes, and you cannot even expect how they are going to react. So I think that if you specify the bit, you have to, also specify what nodes are supposed to do with that bit. And I agree with the, concern that you might use this bit to actually DOS an IPv4 network. I'm not saying that it is necessarily a showstopper, but it's certainly an important thing.
Yep.
Jen Mikova. I just realized it's a perfect example of the situation when people should consider deploy IPv6, because if they still think it's not there, it's actually there on their network, and they still need kind of IPv6 security even in the network, which, as they believe, is before only, right? So it's actually a good thing that you might turn completely before on your before only network using IPv6, which you believe doesn't exist.
Yeah, because it's really not a v4 only network, because all the dual stack hosts are running v6 all the time.
Rob Evans, just quickly, I guess, we've been talking about the main reason for this is on a managed network. And the difference we're talking about now is between a managed network and a badly managed network.
So why don't we just do a non-binding call then, which will so the people who think they would, if there had been a binding call, would have hummed for a support of adopting this document. Can they please hum now?
Just do a hum for adoption.
Let's do a hum for adoption. The people who are in support for adopting this document somewhere, please hum now. And the people who do not think we should work on this document, please hum now. Okay. There's yes, we take that non-binding hum into consideration, I think, and we should talk to Sunset 4 as well, for sure.
Thank you.
Thank you. So, performance measurement. Is that? So this finished the active working group or documents that have active working group discussion, and now we're on the four last documents are now going to be short introductions to new documents. If you have 10 minutes. Okay.
Thank you. Okay, this is the same presentation we have done this morning also to V6 OPS. We want to present this methodology to IPv6 folks in order to allow the application of this methodology also in the IPv6 context. So the RFC 8321 has been published during January. So this is just a slide to recap the main points of this methodology. The alternate marking method is based on the marking batches. So every marking interval, the packet mark can be changed between two values, red and blue. Red and blue means that we can flip one bit, or we can change between a label value. When the red packet counters are running, the blue counters are still, and vice versa. So in this way, we can take the packet counters for each batches, and by comparing the counters of the same batch between several endpoints, we can calculate in a very simple way the packet loss. Also, the delay and delay variation can be measured with these methods. What are the main strengths? The main strengths of this method that it works on real production traffic, so there is no injection of syntactic traffic. It works also in case of out of sequence. So if you have reordering at the edge of a batch, you can overcome this problem because you can take the counter in the middle of the following interval, so you don't have any out of order issue. This method works in case of also on not synchronized networks because the marking boundary is an auto-synchronization signal over the network. So you don't need a strict synchronization between the endpoints. And it works without OM packets. So OM packets don't work in case of out of order and in case of packet loss. So in case you have your OM packets get lost, you cannot make the measure, but instead the marking boundary is still valid also in case of packet loss and reordering. So this is just a quick view of the application, of the main application within IETF. So we have some proposal in BEER working group, in SFSC, and in NVO3, when you can see the header where we have reserved 2 bits for the application. So RFC 8321 can be applied if we have 1 bit or also 2 bits. So there are several alternatives for the application of the methodology. There is also an application on the MPLS, for the MPLS RFC 6374, where the synonymous flow label is dedicated for the flips methodology, the marking methodology. And there is also another variation of this method in Quick that is also called spin bit method. Regarding the delay, as I mentioned before, there are 2 variations. So we can use the single mark method where we have just one flag, L flag, that can be used. And for the delay, we can consider the first or last packet of a batch that is the time reference for our delay calculation. But this method is sensitive to packet loss and packet reordering. There is another variation that is a little bit more complex that is based on the calculation of the average timestamp. So each endpoint can calculate the average timestamp for each batch, and by comparing the 2 average timestamp between 2 endpoints, you can calculate the average delay, that is the mean delay. And the same things can be applicable for delay variation. Double mark is more flexible because you can use one flag for packet loss, and the other flag, D flag, allows to select some special packets, a set of market packets that are fully identified over the network. And by comparing the timestamp of these packets along your network, you can calculate the delay. So if you have 2 bits, it's better. You can make a best measure. Also because with the double mark, you can calculate maximum, minimum, the percentile values, and so on. There is another variation of a double mark method with the using of just 1 bit, because you can use the opposite bit of the current interval. And so with 1 bit, you can apply the double mark method. It is described in compact alternate marking draft. So what about IPv6? After this short recap, we know that each layer is responsible for its own OM. So we have some, as a Telecom Italia, so as a service provider, we have made an implementation of this method for IPv4. In IPv4, there is no space to reserve some bits to apply this methodology. We use the SCP, but we cannot standardize it. But we would try to do that with IPv6. So there are some alternatives that we can analyze. For example, we can apply the methodology to an extension header using an existing one or a new one. encode the marking methodology into the IPv6 address, or using 2-bit from the flow label field. So each of these alternatives have some issues, because if we use the extension header, this seems less backward compatible. So a proposal can be to use an existing extension header instead of define a new one. Otherwise, we can use the destination address to encode this, but also this is a little bit expensive. And the other alternatives is to use the flow label field. But you may know that the flow label is also used for load balancing, as reported in RFC 6438. So we should overload this field in case we want to use 2 bits from flow label.
Excuse me, so could I just ask a question for clarification? The packets you're measuring here are packets that could transit your domain, your measurement domain, right? They're not originating, you don't control the originating nodes that generate these packets, do you?
I think that both use cases can be done. If you mention our experiment, our implementation, the marking is made on the border of our domain, on Telecom Italia domain, for example. So when the packet came in our domain, that is a controlled domain, we apply the marking, and then we restore the marking field when the packets go out to the domain.
But I mean, if you change the V6 destination address, for example, I mean, how would you restore that?
Okay, the destination address no, I mean, for example, for the flow label, and probably for the extension header. For destination header is another problem, I think.
Right. But you would talk about header injection here as well for extension headers,
it's
right?
just
right. Or
the idea is just to investigate all the alternatives, but we don't investigate so much the IPv6 address. We have some ideas, but we didn't implement and we didn't experiment this. I know that there will be some problem, but we got some review and feedbacks on mailing list. So there is some discussion about the flow label application, because if we use 1 or 2 bits for marking, we have to just only 18 or 19 bits dedicated for the load balancing. So should this enough to apply the load balancing? Otherwise, we can use, it's better to use an op-by-op extension or a destination option extension. Another question could be, it's better to use an existing extension header or defining a new one. Otherwise, we have also some proposal in MVO3 working group, as you can see in the second slide I presented before. So maybe another possibility can be to use an extensible encapsulation from the other layer. And then also the scope of the draft, that can be, the RFC is experimental, of course, but now we should understand if this draft can be informational or standard, depends. Okay, so as a next step, we did find an agreed way to apply this alternate marking method for IPv6, so not for IPv4, that it's a self-made and homemade implementation, because we use the SCP field that is not allowed for this function. And we want to add also a multi-point alternate marking use case that extend this methodology. It is a generalization for multi-point to multi-point paths. And okay, please comments, question, and other feedback.
So any comments? And I think please keep the focus on where we can find these 2 bits. I think in V6, I guess that's the main question asked. Lorenzo Coletti.
Yeah, you said you can't do this in V4, but you can't do this in V6 either because it's not allowed, right? So I think I do wonder, so that we've got these bits in the flow label and nobody seems to know what we should use them for. I wonder if we should, and on the other hand, like the request always comes up and again, oh, we need to be able to insert bits into the header, we need to be able to impose extension headers and so on. Can we address a number of use cases by just saying, look, 8 of the bits of the flow label can be stomped on by the network, and or whatever, some number of bits, could we gain consensus on that? And if we could, no, we can't. All right.
So, Suresh Krishnan, Heidi hat off again. Like, so I wrote this draft to try to do that, and we didn't get consensus. Like, so 5 years ago, maybe possible. But like, it was like pretty much like very polarizing topic, and I think the main issue is like if somebody's using this for some kind of hash-based load balancing, it shouldn't be too short. Like that was like probably the showstopper. But I'm just saying, right? Like, so I don't mind if somebody tries, but like the last time we did it, it didn't work. And I think repeating the same thing and expecting different answers is whatever, that thing.
But this is the IETF, man. So no, but think about it this way, like the flow label stuff. What is the flow label stuff except, what is it but not essentially like imposing random values onto the flow label? So I guess, yeah. So how's it different, really? How's it different from putting random stuff in the flow label in transit? Okay. Okay. And what? I guess I don't understand why there should be controversy.
Tim Chan, you say this came up 5 years ago and got thrown out? Isn't it since then that we updated the flow label spec to say you can write all those bits to be some random value if it's arriving set as 0, but not if it's already set to some random value. But the problem is, in your case, most operating systems, I don't know, I guess most of them probably set it now.
Right, like, so I wasn't responding to him, but to Lorenzo, like where like give some of these bits for the network to play with. Right, like, so the requirement on the network is that, like, it delivers the packet as it was set in the flow label field.
Yeah, and I guess, I think as I mentioned this morning, the experiments that have been done in V4 have only been with the DSCP, and within a domain where you can twiddle it as it comes in and out, so, which you could do for V6 as well, I guess. Okay.
I think you should look into putting them in the TCP checksum, and because by definition, all these proposals basically like, well, we will invert this transformation when it exits our domain. Use the checksum, because that's like entirely reversible, right? You just recalculate it in the TCP packet. Yeah. Oh, there's UDP, right? UDP and TCP and ICMP, they all have checksums. So you use the checksum, 16 bits.
But this is a TCP, is not IPv6. So if you want to, for example, for a service provider point of view, if you want to monitor the IP traffic of a customer.
And they send what? What do they send? SCTP? Is that what they use? They use TCP and UDP, right? That's what they use.
Yeah, no, I know. But if you want to use the IP layer, I mean.
Well, you don't have
to. If you want to monitor IP layer.
Right, you want to monitor customer traffic. Well, what percentage of customer traffic is TCP and UDP?
But,
is it only 99.9 or is it?
No. The problem is that the customer may have a service layer agreement with the service provider based on IP traffic, not on TCP.
Sure, but you could say, well, only
customer
UDP.
could say, okay, but you are not measuring I want you an SLA on IP traffic, not on TCP.
But what IP traffic are they sending? That's not TCP and UDP.
No, this is a
theoretical question.
Yeah, this is an
but if it's a
example.
theoretical question, it's still a lot better than you were before if you can use the checksum.
Okay, I think we have to continue this on the list.
Okay.
But at least for now, it's an experiment, right? So we can, yes. Okay, super. Thank you. And I think, Fernando, you are remotely, at least you were last time you said something. Can you please lower the gain on your microphone or speak lower or stay a little bit further away from it because your sound was
okay.
Yes, go ahead, Fernando.
Okay. So this is a document that we presented at the last IETF meeting. It's a recommendation on temporary IPv6 interface identifiers. Next slide. So what are the goals of this document? Well, essentially, it is like RFC 8064, but for temporary addresses. So essentially what we do is we specify requirements for generating temporary addresses. We also clarify that nodes are not required to generate stable addresses. And that's it. Again, this is the same as RFC 8064, but for temporary addresses. As a comment in a previous version of this document, the document was proposing or recommending two possible algorithms to generate these addresses. This has been removed and moved out into a different document. So next slide. These are the requirements that we have so far. First, that these IDs must have a limited lifetime. That the lifetime needs to be reduced by security meaningful events. That the IDs needs to be different for different prefixes. This is something that is different from what was the case in RFC 4941. That they should not embed layer 2 addresses. Obviously, that they must be difficult to predict by an outside entity, and that they must be semantically opaque. Next slide.
I think you dropped off the last sentence there, Fernando. Can you repeat?
Yeah. That the last few of the requirements is it should embed a layer 2 address, must be obviously difficult to predict by an outside entity, and must be semantically opaque. Next slide.
Okay, and please stay a little further away from the microphone, or turn down the sensitivity a little bit, because we get distortions in the room.
Okay.
Not get excited, and be very calm and collected and speak slow.
So the question for the working group is whether it should be adopted as a working group item. Or that's what we would like to hear or know from the working group.
So now you just dropped off again, Fernando, but may I suggest, since you have two documents that are kind of overlapping in scope, that we take that discussion at the end of the two documents?
Yeah, it's fine.
Okay, sorry, now we can't hear you at all, Fernando.
Yeah, it's fine.
Okay. So any comments on this draft and these requirements now? Otherwise, you get a chance again after the next draft as well. Okay, let's go to the next one.
So essentially, this is a 4941 document. We started some work on this document based on the suggestion that we received during the last 6-month meeting. So originally, we were doing everything in the previous document. And what we did now is split that work, keep the requirements in the previous document, which mimics what we did in RFC 8064. And this one is a BIS document of 4941. Next slide. So these are problems with RFC 4941. First of all, the way the document is written, it prevents the use of only temporary addresses. Then it also recommends to use the same interface identifier for multiple prefixes. So obviously, if you use the same interface ID for multiple prefixes, that allows the correlation of network activity between those two addresses. Also, the same interface identifier is employed, is reused when the node moves from one network to another. 4941 also limits non-deprecated addresses to one per prefix. And also, well, in 4941, because of when it was written, there were things that needed to be updated. Like, for example, now all the bits in the interface ID are opaque, so that was changed too. Next slide. So what this document does, essentially try to address the problems that were described in the previous slide. What we did was, when it comes to the algorithm, keep all the text that has to do when the addresses are generated, the timing, and so on, and but replace the algorithm itself that you use to compute the interface ID. For many different reasons. Among them is that, for example, the algorithm mandated to set the universal local bit according to the specs at the time, and that changed, etc., etc., etc. So what we did in this respect is we took the two algorithms that were in the previous document and replaced the existing algorithm in 4941 with these two. And obviously, being a BIS document, it would formally obsolete RFC 4941. Next slide. This is just to know the two different algorithms that are proposed as a replacement of what was in 4941. First one is just pick a random number, simple. Pick a random number of as many bits as necessary, and that's it. The second one is essentially a modification of 7217, in which you add, for example, a time parameter, so that you can essentially use exactly the same algorithm with these minor modifications. So you don't need to have like two completely different algorithms for a stable and for a temporary address. Again, these are two possible alternative algorithms. We are not saying you should do one or you should do the other, but here's two from which you can possibly select one. Next slide. And same question as before. So as I mentioned with the previous ID, we had presented part of this material in previous IETF meetings, and the suggestion was made to produce a 4941B. So this is essentially in response to that.
Okay, questions?
Hi, Fernando. This is Dave Blanca. I'm just, since I think we have a couple minutes, I wanted to mention what I just sent to the mailing list about the temporary IPv6 address draft. One of the issues I see in it is that it says that the address, presumably the next interface identifier, must not be the same as the previous one, is the way that I'm reading it. And I think that needs to change, because it suggests that a host implementation would have to remember the address it used before. And so there's just a wording change. I think we can say, instead of saying it must be different, we want to say it must be most unlikely that it's the same. With the random number based IIDs, there's ever such a small possibility that it could be the same, and we want that. Because if you don't allow it to sometimes be the same, then you're introducing a pattern, which the draft later says you can't introduce a pattern, because it's not semantically opaque if you're remembering something about what was before and disallowing specific values. And then that happens across time, and it also happens across space. So you could imagine a machine having hundreds or hundreds of thousands of IIDs on it simultaneously. It's going to look across those, and you don't want to disallow it from being able to choose one of the addresses that's already there, because that makes it more predictable. So that's what I was talking about there. It's in the mailing list, and then I just had a couple other suggestions about how we could word it. But the idea is make it something that an implementer could actually do, instead of saying something that's so difficult to enforce.
Yeah, I responded to your, thanks for the comment. What we meant is that the identifier should be statistically different. So we don't want that, like you do in 4941, in which you just generate some value and reuse it for different prefixes. So that's essentially what we meant. And we don't expect you to actually remember about previous interface identifiers.
Right. So I agree with you. I'm not disagreeing with you. I understand what you meant. I just want the document to say something that someone could actually do. The point that you just made, oh, no, I've forgotten it. I'm sorry.
So what I'm saying is that it's not that we expect that you compare the interface ID that you just generated with previous ones, or it's just that we don't want you to reuse the same interface identifier deterministically. So that means that it should be statistically different. That's what we're saying. So it's a wording thing.
I don't think that is a wording thing. I don't think statistically different means something. I think you want to go towards it's improbable. And we can say it's most improbable, it's extremely improbable, it's highly unlikely, but really that's it. You can't say
how do you define improbable?
That's in the dictionary.
Statistically unlikely.
Tim Shine, you say you don't have stable storage, but wouldn't the existing temporary address be put into a deprecated state for a period of time so you'd know it was associated with the host anyway? I'm a little confused about having to remember it.
Sorry?
Okay. But yeah, I think what you need to focus on is the property of the address you're generating, not on relative to the other addresses that you have. I think the other thing that's important, and I think that's what's happening on the list, is to have something in there about the frequency with which you change them. I know there is something on 4941 about that, but improving that would certainly be a good thing. I think most operating systems, you tend to see them flip them every 24 hours for something, so it becomes very predictable. But making sure that that's clear, that varying that quite significantly is a good thing.
Yeah, that's part of the goals.
Yes, and not predictable in the way that you do it.
Lorenzo Colidi, two things. Number one, I think the algorithm based on 7217 is a bad idea, because it's actually, if you manage to figure out what the key is, it's basically predictable from now until the end of time. And depending on what F is, if it's sort of not secure, you sort of end up being, it sort of ends up being possible to attack even if you don't leak anything. I really don't see what that gives us above being random, particularly in the presence of collisions. The other thing I wanted to say is, I think it's we should maintain somewhere in the specs of the possibility of using Slack with a randomized MAC address for simple implementations. Because right now, like, we have this distinction between temporary and stable, and that sort of address is neither temporary nor stable. It's sort of randomized at a certain degree, but it doesn't meet your definition of stable in this document. And I think we should be able to keep doing that, because I think it's simple and useful for privacy.
So I have a comment here from the Jabber, from Peter Hessler, saying, is there a requirement to use any specific algorithm, or can an implementer use any algorithm they like? I think that's part of what Lorenzo is.
Well, there are two different documents. So the first one, which is the one on non-stable interface identifiers, essentially sets the requirements, and as long as you comply with those requirements, you're fine. Then 4941Bs specify some algorithm that can comply with those requirements. So the requirements and the possible algorithms to comply with those requirements are separate. So you could implement your own if you want. You don't need to follow the specific algorithms that we are giving you as examples. But still, that's actually the goal or the purpose of the previous document that I presented, is to set the requirements very clearly, so that if you want to use an algorithm of your own, you know what the properties of that algorithm should be.
Fernando, so one comment about the BIS document. It would have been better if you had published the 0 version, which was the baseline of the current RFC, because I tried looking at the diff from your 00 to the RFC, and it's really messy to see what the changes are, because the formats are different and so forth. So I would find it useful if you would do a new draft that was only the sort of turning the original RFC into a new draft, and then publish your changes in a draft after that, so we can sort of follow the changes easier with the diff.
What I did is I produced this version with the latest XML source that Suresh had. So honestly, I didn't do the diff with RFC 4941, but the XML that I used was the last one that was available.
Yeah, I know, but when I looked at the diff to try to see what the changes you made, I found it hard because I had to compare it with the RFC, and this was in internet draft format. I think doing BIS documents, it's better to first do a 00 that does not have any technical changes.
Yeah. So Fernando, if I summarize what Bob is saying, like the BIS 00 should be identical to 4941. Does that make sense? Like, so
it does. The question is, how do we do that without with XML? Because the way in which I produce this 00 version is with the latest version of the XML that we had.
Right. So like
the other
what is
option
different?
would be
So what's different is the RFC editor edits on the document, right? That's not in the version of the XML I had, the last version. So so there is a tool like that the RFC editor is using now, like it's an experimental tool, used at your own risk, which can generate the XML. Okay, so I can probably like run 49, 41 through it and give you the XML, so you can use as 001. So like, but the right way, Bob, like personally, like, you know, what I like on a BIS is the changelog, right? Like you did for like, you know, the 1981, so like, or like 8200. So I think like that would be like really good if you have just a changelog of the things you do in addition to this. Like
It is.
right? That's
it is in the document.
No, I understand, but like, but I think like Bob is saying like the baseline is not 49, 41. I think he's not saying like anything else. He's just saying like the 00 of this should be identical to 49, 41, and then all the changes, not really anything else. He's not saying anything else, Fernando.
Yeah, the 00 should be the RFC content should be identical to the RFC. The only changes should be formatting into an internet draft.
Yeah, boilerplate and dates and author names. That's it.
So I think we need to wrap this up so we have time for the last presentation. Do you want to be extremely quickly?
Yeah, let's delete the text that says requirements on algorithms. Let's just say it needs to be random. It's just easier for everyone to understand, and there's no risk of putting an algorithm that the developer thinks satisfies the requirements but doesn't actually. Yeah, exactly. Let's just say it needs to be random, period.
Okay, super. Greg, are you in the room? Yep. You got 5 minutes. Thank you, Fernando.
Okay. Next slide, please. Okay. What? Okay. So what we see the problem? Why this draft came about? Many OEM functions they require identification of not only source but the path used, and that's especially important in segment routing. So segment routing IPv6 does provide with the use of segment routing extension header and compliance with its requirement. As segment routing in MPLS data plane, as well as unified SR, which effectively is SR MPLS over UDP, is not. On the other hand, scalability of SR with IPv6 network is a concern because of use of 128-bit long SIDs. Other hand is that SR MPLS, because it uses MPLS identifier, 20-bit identifiers, is much more scalable, especially if we want to encode service function indices, IDs. And to support this is that IGP extensions for the segment routing already are capable advertising 20-bit long SIDs as well as 32-bit long SIDs. So what we propose? We propose to make segment routing header multifunctional. Not only be capable advertising 128-bit SIDs, but be able to recognize that it carries either 20-bit SIDs or 32-bit SIDs. Their solution is pretty simple. Allocate 2-bit long as field, which can be encoded as 0 for 128 to be compatible with current implementations that the current draft suggests that this field to be zeroed on transmission and ignored on receipt. And use 2 values for encoding 20 bits and 32-bit SIDs, and then leave 1 more for future use. So the transit SR nodes will operate the same way as described in a segment routing header draft, and egress SR node definition will be provided in the future updates. So the next steps, we would appreciate reviews, comments, suggestions, questions. And the question we have for the working group is to think and discuss whether this may proceed as an independent draft or better to be merged with the current SRH draft. Thank you.
So I think we have time for one question. So, by the way, have you presented this in spring? Because
spring, I asked for spring, but spring agenda is so tight. They apologized and said, no, not this time.
Because that certainly is something we would need to discuss with the spring chairs, I think, if this would belong here or there. Yeah.
Okay, I think that if you have your own, I personally think that it's probably belong here because it proposes update to the format defined in this group. But I agree that spring working group should be informed and be aware of any decision made on a path taking for this draft, whether it's merged to existing draft or decided to be independent draft.
So Darren, please have the final word.
Yeah, Darren Duke, Cisco Systems. So I did read the draft, and you have an idea in it, but I don't see anything there. So I don't think you're at a point where you can ask either of those questions yet. I guess I don't see how this would get used in actually any use case right now. Not that it can't be, but you haven't described any of that. So I don't think we're there. That you want to keep building on it on the list or issue some more versions of it.
Yep.
Maybe that should be the path you take.
And this was definitely just a 5-minute slot to introduce the draft. So I think we're done, Ron, if that's okay. And we'll see you in Bangkok, Montreal? Yeah. Thanks, Greg. And the blue sheets, can you bring those up to us, please? Thank you. We're done again.
Yeah.